Welcome to our channel Quaint Cosmos. Today we are diving into a fascinating topic known as nanosensors. Yes, nanosensors. This is the topic. You have heard the name of nanotechnology, and this is nothing but nanotechnology. The topic nanosensor, this is also a kind of nanotechnology. And nanosensors, this is used in the field of medical technology. At least in this video I am going to discuss the use of nanosensors in the field of medical technology, especially cancer, and more specifically it is breast cancer. Yes, early diagnosis of breast cancer is possible by the use of nanosensors. So since the term nano is here present in the word or in the term nanosensors, that means it is very small. The size of these sensors, means size of the nanosensors, vary between 1 and 100 nanometers. You know, nanometer is equal to 10 to the power minus 9 meter, means 1 nanometer is equal to 10 to the power minus 9 meter, which is very small. So range varies between 1 and 100 nanometer. This is the size of the nanosensors. So nanosensors are nothing but nanoparticles. Yes, these are nanoparticles. Nanosensors may be of various types, such as magnetic nanosensors are there, then electrochemical nanosensors are there. Again, you will find optical nanosensors, those are also present. And all these types of nanosensors are used for different purposes. Here we are talking about only magnetic nanosensors, and it is used in the field of cancer detection, especially breast cancer. So the type of the sensor is what? Magnetic. That means here the nanoparticles are magnetic in nature. What is done in this case, in case of cancer detection, iron oxide nanoparticles are used as the magnetic nanosensors. Iron oxide nanoparticles. And one more requirement is there, that is the targeting agent. As a targeting agent, antibodies are normally used here in case of cancer detection. So antibodies, that means the nanosensors here, the magnetic nanosensors are functionalized with targeting agents such as antibodies. And what is the benefit of these antibodies? Benefit of these antibodies, if I talk about only breast cancer, then in that case, you know that in case of breast cancer, biomarkers are there, such as HER2. This is a kind of protein, human epidermal growth factor receptor 2. In short, this is known as HER2. This is a kind of protein, and which is very often overexpressed in case of cancer cells. That means these are kind of biomarkers. So the antibodies which are attached, means I have already mentioned that nanosensors are functionalized with targeting agents such as antibodies. So those antibodies have the affinity to bind with the biomarkers available on the surface of the cancerous cells. And here I have already mentioned the special protein which is overexpressed in numbers is HER2. That means whenever it is injected, means the nanosensors are injected into the patient's body, the nanosensors, so it is in the form of liquid. It is injected into the patient's body. So the nanosensors circulate throughout the patient's body without interacting with the normal cells, means healthy cells. But whenever those nanosensors come in close proximity with the cancerous cells, and if they find those biomarkers, then they readily approach to the biomarkers to bind with them. Now, this thing has already happened. Means injection means already nanosensors are present in the patient's body. Right? Now if an external magnetic field is applied, then those magnetic nanosensors will respond to this magnetic field by generating magnetic signals. And those magnetic signals can be detected easily by using advanced imaging technologies, imaging techniques, such as MRI is there, that is a magnetic resonance imaging. Then MPI is there. MPI means magnetic particle imaging. These are medical diagnostics techniques, or better to say, medical imaging techniques. Okay, so these techniques can be applied to detect those generated magnetic signal produced by those antibodies, means produced by those nanosensors, which are now attached to the only cancerous cells. That means by using these magnetic nanosensors, early detection of the cancer is possible. Why early detection? Because in the very beginning of the cancer, means in the early stages of the cancer, the I have already mentioned that overexpressed HER2. HER2 remains overexpressed in cancerous cells. But when the concentration is very low, means when the concentration of the biomarkers is very low, in that case also, the MRI can detect the presence of biomarkers. That means early detection is possible, and since early detection is possible, that means treatment becomes effective in that case. So in that case we get improved patient outcome. That means here sensitivity of the biosensors are very high, because they can detect, first of all, they are very small in size. Size is nanoscale level. They are very small in size, and secondly, they can easily detect cancerous cells when concentration of the biomarkers is very low. In that case also, that means sensitivity of the magnetic nanosensors are very high. Again, real-time monitoring of the disease, means disease progression, in real time is possible by using such imaging techniques. So there are so many advantages if nanosensors are used. Anyway, so this was all about today's topic, nanosensors in the field of breast cancer. Means nanosensors in breast cancer. Okay, I have chosen a specific topic, only breast cancer. So many diseases can be detected by using such magnetic sensors. Later, I'll make separate videos on different diseases and detection techniques, as well as treatment procedures available. Anyway, so this was all about the topic magnetic nanosensors. So this is the end of this video. Thank you. Thank you for watching this video.